these are the notes for lesson 2.2, slope and rate of change. So by definition, the slope is the ratio of vertical change to horizontal change, or the change in y over the change in x. So again, the little delta or triangle symbol means change. So if we were to look at a table of values, we could determine what the slope was by looking at the pattern that we see in the y values and the pattern that we see in the x values. So if y was going up by 2, that would be the change in y. If x was going up by 1, that would be 1. And 2 over 1 would be our slope. So again, the numerator in our fraction in our slope is the change in y. The denominator is the change in x. And that's just one way of looking at slope. There are many different ways that we can look at slope, but they all mean the same thing. It's all referring to slope. The second way we can find the slope is if we are given 2 points. So if we are given the points x1, y1 and x2, y2, we have a formula for slope that says that if we subtract the y's and we put that over the difference in the x's, that will find us the slope as well. We get this formula from the idea that slope is the change in y over the change in x. The other way we can find slope is from an equation. If you remember, this equation y equals mx plus b is called slope-intercept form, and we're going to talk more about this as well later on. And in slope-intercept form, the m, or the number that is multiplied by x, is the slope. So whenever we have an equation that is in slope-intercept form, we know that the number that's multiplied by x, or our m value, is our slope. The third way we can determine slope is from a graph. And if we're looking at a graph, if we find 2 points, we know that the slope is the rise over the run. And this is something that we talked about in class before as well. Again, slope is rise over run. And we're going to look at some examples of that in just a second. So again, there's many different ways that we can find slope, or ways of representing slope, but it is all slope and it's all the same thing. So the first example we are looking at is to find the slope of the line passing through -1, 5 and 2, 3. So again, we are given 2 points. So we know that the formula that we are going to use is m equals y2 minus y1 over x2 minus x1. So what we want to do is look at our points and we can label them x1, y1, x2, y2. So we're going to take our y2 value, so 3, and we're going to subtract 5 from that. So 3 minus 5. And again, this is m equals. And then we're going to take our x2 value, so x2 is 2, minus x1, which is -1. And then we can determine our slope. So 3 minus 5 is -2. 2 minus a -1, remember adding the opposite, or subtraction is the same as adding the opposite. So 2 plus 1 is 3. So our slope is -2/3. So the first example, we looked at finding the slope given 2 points. The next one, we're going to look at finding slope if we are given a graph. We still need to find 2 points on the line. So when we are looking at the graph, in this example, they gave us the 2 points. So right here, we're positive 2, 3, and right here, 0, 0. But you want to find 2 points that are on the graph. We could also use -2, -3, because that one's also on the line as well. So you want to find 2 points that are on the line. You want ones that intersect at a corner. That way they are even points. It's just easier to work with and we don't have to round. So once you have found those 2 points, then we can find the slope of the line. So from here, we are going to start at 0, 0. If you remember, the slope is rise over run. So from the point 0, 0, we are going to go up 3, and then we go over 2 to get to the next point on the line. So our slope is 3 over 2. Now we could have started from the point -2, -3, which is down here. Again, we'd still have to go up 3 and over 2 to get to the next point. So wherever you find 2 points, your slope should be the same for each of those points. So again, we go up 3, which is our rise, and to the right 2, which is our run. We went up and we went to the right, so we know that they're both positive. If we go to the left or down, we know that that means that our slope is negative. Now we can double check that our slope is correct in terms of the sign. So if we have a positive slope, like we did here in this example, it should be rising from left to right. So if we look at our graph, we notice our line is going up or rising from left to right. So it should have a positive slope. So a positive slope would be rising from left to right. Negative slope is falling or going down from left to right. A zero slope is a horizontal line or left to right. Undefined is a vertical line or up and down. And there's a fun little picture that will help you remember these. So we have a positive slope and a negative slope. Our vertical line is undefined, and our horizontal slope has a slope of 0. So we can make a face. Again, that will just help us remember what slope goes with which type of line. In our third example, we're finding the slope of the line below, and we are given an equation. So before we can find the slope given an equation, we need our equation to be in slope-intercept form. And if you remember, slope-intercept form is y equals mx plus b. So what we want to do is we want to solve for y. We want y all by itself, and then it will be in slope-intercept form so that we can figure out what the slope is. So in order to get y all by itself, notice that 2 is multiplied by y. So to get rid of the 2, we have to divide everything by 2. So that gives us y equals, the negative 2 divided by 2 is a negative 1, or a negative 1x, plus 4 divided by 2, which is 2. And again, once we are in slope-intercept form, we know that m, or slope, is the number that we are multiplying x by. So in this case, our slope is negative 1. And whenever you see m, you should always think slope. We can use slope to determine equations of different types of line. Two special types of lines are parallel lines and perpendicular lines, and each of them have special properties as far as slope is concerned. Parallel lines, if you remember, are two lines on the same plane which never intersect. Now, if they're never going to intersect, they have the same slope. So we know that lines are parallel if they have the same slope. So if we have the equation y equals 1/2 x plus 2, we need to write an equation of a parallel line to this line. So y equals mx plus b, or this equation is in slope-intercept form. So if we look at the number multiplied by x, we know that our slope is 1/2. So to write an equation of a line that is parallel to this equation, we also need the slope to be 1/2. So we have y equals 1/2 x. And in order to have a parallel line, the slope has to be the same, but the y-intercept has to be different. So our y-intercept for this equation is 2, so we just need to add on any other number. So I'm going to add on 5. So again, the y-intercept can be anything except for 2, and since these lines have the same slope, they are parallel. The second special type of line is perpendicular lines, and these are two lines on the same plane which intersect at a 90-degree angle. And perpendicular lines have opposite reciprocal slopes. So for example, if we have y equals 1/2 x plus 2 again, we know that this is slope-intercept form, and we know that the slope of this equation is 1/2. So if we are going to write an equation of a line that is perpendicular, we want a slope that is the opposite reciprocal. So opposite refers to the sign. So if we have a positive slope to start out with, the opposite of that would be a negative. If we start out with a negative, the opposite of that would be a positive. So the slope of our perpendicular line is going to be negative, since our beginning slope is positive, and we want the reciprocal. So we know that the reciprocal of 1/2, we just flip the fraction, so that is 2/1, or just -2. So if we write our equation, y equals -2 is our new slope. And again, we just need a different y-intercept. So plus 3. So the equation of a line that is perpendicular to y equals 1/2 x plus 2 would be y equals negative 2x plus 3. And again, the slope, you could have any equation as long as the slope is the opposite reciprocal and the y-intercept is any number except for 2. Example 4 says, are these lines parallel, perpendicular, or neither? So again, parallel lines we know are going to have the same slope. Perpendicular lines have opposite reciprocal. And if they're neither, the slopes aren't going to have any kind of relationship. So in order to determine whether these lines are special lines or not, we first have to find the slope of each of them. So for line A, we are given the points 1 and negative 2 and 3 and negative 2. So the first thing we want to do is find the slope. If we are given 2 points, if you remember our equation given 2 points is m equals y2 minus y1 over x2 minus x1. So for line A, to find the slope, we first want to subtract our y values. So y2 is negative 2, y1 is negative 2, so negative 2 minus negative 2 over our x2 is 3, and our x1 is 1, so 3 minus 1. 2 minus a negative 2, remember subtracting is the same as adding the opposite, so this is 0, over 3 minus 1 is 2, so our slope for this line is 0. Now if you recall from the previous page, if we have a 0 slope, that is going to be a horizontal line. Then we need to find the slope of line B. So again, we first start with our y value, so y2 is going to be 4 minus 4, or our y1, over our x2 is 0, and our x1 is negative 5. 4 minus 4 is 0. 0 minus a negative 5, remember adding the opposite. So this is a positive 5. Again, 0 over 5 is 0. And again, that is a horizontal line. So notice that they have the same slope. Since they have the same slope, we know that that means that these two lines are parallel. Example 5, again, determining whether these lines are parallel, perpendicular, or neither. Again, our formula for that is y2 minus y1 over x2 minus x1. So I want you to take a second, pause the video, and I want you to find the slope of line A using the formula that we just talked about. So for line A, you should have gotten a slope of positive 7. We took y2, which is negative 1, minus 6, which is our y1, and then subtracting 2 minus 3 to get negative 7 over negative 1, and that would give you a positive 7. Now, some of you might ask whether the order that we subtract these in matters. As long as you start with the same x or y value, then it does not matter. So we could do this in the opposite order. We could say that 6 is our y1, and then subtract 1 from that, but then we'd have to start with 3 and subtract 2 from that. So 6 minus 1, that should be negative 1. So 6 minus negative 1 would be 7, and then 3 minus 2 is 1. So you still get a positive 7. So again, it doesn't matter which coordinate is your x1 or your y1, as long as they are consistent. So now I want you to pause the video, find the slope of line B, and then we'll determine whether they're parallel, perpendicular, or neither. Your slope for line B should be negative 1/7. So again, we take our y1 value, which is 1, subtract 2. Then we take 6 minus a negative 1. Again, subtracting is the same as adding the opposite, so that gives us a positive 7. So we get a negative 1 over 7. Now, if we look at negative 1/7 and 7, we notice that they are opposites. One's positive and one is negative. And we know that the reciprocal of 7 is 1 over 7. So we know that these slopes are opposite reciprocals. So therefore, these lines are perpendicular. So again, slope can be represented in many different ways, but we are always talking about the change in y over the change in x, and you'll need to know those different ways that slope is represented for all the different things that we are going to talk about. you.